John's come all the way from Singapore to give us a bit of a talk on the new systems. Let's give him a round of applause for that. Thank you. And from my short chat with you earlier, he's got so much knowledge. He's been around for almost a decade now and seen technology basically advanced, and he knows so much about it. Thank you so much for joining us today. Can't wait to hear about the new chips. Thank you.
Thank you. I just saw those chuckles. It's good to see some familiar faces. It's been a while since I've gotten in front of everyone, so I hope you enjoy what I've got to say. Can we go to the next slide? Okay, so we're just launching the 40 series laptop GPUs. We started launching them on desktop end of last year, and we're really excited to bring our Ada Lovelace architecture in the 40 series to laptops. We're seeing a massive leap in efficiency, and we're also being able to introduce some really cool new technologies that I'm going to drill down into. So can we, next slide? So Ada Lovelace is our new architecture. It's built on a TSMC 4M process. What we've done is gone through our GPU and updated every single part. We've updated our shader cores. Can we go back? Sorry. We've updated our ray tracing cores, our tensor cores that handle the AI processing, and we've added a optical flow accelerator, which is a really important thing when it comes to our DLSS 3 technology. We've also updated the video engine, so we can now handle AV1 encode and decode. We only had decode in the past, and the top-end GPUs actually have dual AV1 encoders. Next slide, please. So the big thing with Ada is that we've been able to really increase efficiency. So what we're seeing now is for the 70 class GPU, a much more power efficient architecture. So in this case, the RTX 4070 is using the same sort of power that an RTX 3050 will. And this is really important in laptops where you're really constrained. Next slide, please. So we introduced real-time ray tracing acceleration 5 years ago now with our Turing architecture. And we've seen a really great uptake of ray tracing with game developers. But the thing about ray tracing is that it's really computationally expensive. And especially as you start getting up to what you call full ray tracing or path tracing, which is kind of the holy grail of real-time graphics. So in this case, you're looking at 23 frames per second in Cyberpunk. This is with the Psycho ray tracing settings, everything turned up to max. So in order to get this, get an increase in performance, if we go to the next slide, we introduced our DLSS super resolution technology, which went through a couple of generations. But what DLSS or DLSS2 does is takes a lower resolution image and a whole lot of information from the game saying where everything's moving. These things called motion vectors. We run it through an AI network on the tensor cores, and we're able to spit out an image that's low latency and much higher frame rate than that initial image. So with Ada, what we've done with our optical flow accelerator, if we move to the next slide, is we've added what we call frame generation. What frame generation does is it actually creates a second frame, an intermediary frame, completely from an AI network, using all the inputs from the DLSS2, as well as what we call optical flow field, which actually analyzes the image and can work out where things are moving. So it's combining the game engine data with actual analysis of the image on screen. And what we end up here, because we pair it with our Nvidia reflex low latency technology, is a frame rate, can we go back? A frame rate that's now, if you remember the initial purely just ray traced game was running at 26 frames a second. We're now over 100 frames a second. And this is really what we're needing to do to really move graphics forward if we want to increase fidelity and keep performance up. So this is what we call neural rendering, or leveraging AI as well as traditional rendering methods. So if we move to the next slide, what we're actually seeing when you're running DLSS 3 is you're only rendering 1/8 of the pixels. Everything else is coming out of the AI network and with a whole lot of smarts running on the RTX GPUs. So this is a really big achievement from our research people, and something that really is going to push game performance forward. And there are really significant benefits, especially on laptops, where you're so power constrained and you're so constrained by CPU and GPU performance. So if we move forward, the big thing is that for us, it's not just about coming out with the tech, it's about seeing developers implement the tech. So as of today, with the release of Returnal, there are 27 games available with DLSS 3, which runs on the 40 series GPUs. Overall, there's over 250 games that use DLSS Super Resolution. And we're seeing more and more titles. There are 50 DLSS 3 games that have been announced, when you include what's coming out soon. So it's a really exciting technology that people using 40 series GPUs can leverage today, and we'll keep being able to leverage. Next slide. So this is a really core part of what we call our Max-Q technologies, which is a series of technologies that we continue to build on to make gaming laptops better, in order to enable thin and light form factors like the ones you see here. Max-Q is this package of technologies that make this happen. So with the 5th gen of Max-Q that we're launching with 40 series, we have DLSS 3, but then we have a lot more memory control and ultra-low voltage GDDR6 memory. This really allows for the best power and performance. Next slide. So this just gives you a bit of a rough idea. We can make sure you get the slides later. No need to read all of it, but just a couple of things I want to highlight. We're seeing, and this is the 4090 compared to the 3080 Ti, which was last generation's flagship. In creator applications, we're seeing around 2 times boost in performance. In games, traditional rasterized games like Assassin's Creed, Valhalla, Borderlands 3, we're seeing about a 50% improvement. But then when you get into the ray trace titles, and the ones with DLSS, we're starting to see almost a double improvement. The really interesting one for me, there's Portal with RTX, which uses this path tracing, this full ray tracing tech. And by using Ada Lovelace and DLSS 3, we're able to get triple the performance. And this is really indicative of the most advanced games moving forward. The other one that's really interesting is Microsoft Flight Simulator. Microsoft Flight Simulator is a game that's famous for being CPU bound. No matter what your GPU you throw at it, it will be limited by how good your CPU is. And these new Intel CPUs are great, but you still get an upper limit. DLSS 3, because the work is done on the GPU, is the only way that you can increase performance in these titles. And so that's why when we see over 2 times performance boost, it's really quite impressive. Next slide. So this is the lineup of GPUs that are available. As I said, we'll supply the slides, so no need to try and jot it all down. But there's a full stack of GPUs coming out for laptops, and we're really excited to see how MSI are leveraging them. And that's it from me, I think.
Give it up for John, everybody.